Welcome back. We noticed that using an ideal gas as a fluid, we can set up a number of temperature scales. However, to do good science and good engineering, we need some standardization. Arbitrariness will not do. So we define a standard scale which is used now as the scale of temperature, and that is the ideal gas Kelvin scale of temperature. Because it is an ideal gas scale, we use as earlier an ideal gas in our system, in our thermometer. So we have an ideal gas in our system. We know that an ideal gas is an approximation of a real gas, but if we use a real gas at low pressures, behaves like an ideal gas. Helium has been found to be a very good candidate. It has a fixed mass, it is a closed system, and we can measure its pressure and temperature. Then we decide on a fixed point. For the fixed point, the state used is water, pure water, but at its triple point. Now we know that water exists in three phases: solid, ice, liquid, water itself, and gaseous or vapor phase, which is steam. However, at a given pressure and temperature, usually only one of these three phases will be found. However, we know that at 1 atmosphere and 100 degrees C, we have both water and its vapor steam living together in the same system. If you go on reducing the pressure and temperature, you will find that at approximately 0.01 degrees C and a pressure of approximately 0.006 bar, both are approximate numbers. Okay. We have a triple point, that means ice, solid, water, liquid, and steam, vapor. They exist together, and the advantage of using such a state of water is that moment we reach this triple point, our temperature is fixed and our pressure is fixed. Pressure at triple point, temperature at triple point. And this temperature of the triple point, the reference state of water, is now defined to be just the way defined the two fixed points for the Celsius scale of temperature, 0 degrees C and 100 degrees C. We define this to be 273.16 Kelvin. K is the unit of temperature, the full name is Kelvin with a small k, the short form is capital K. A question that immediately arises is, why this? We will look at it later. This is a matter of convenience and to align the scale with some other historical scale, particularly the Celsius scale of temperature. Now the fourth stage. How do you measure the temperature of our system? So what we do is we create a system, the reference system, which contains water at its triple point. We bring our ideal gas, our thermometer, in contact with it and see to it that thermal equilibrium is established. So the state of this system and the state of our gas would be a pair of isothermal states. And now we measure for our thermometer system which contains an ideal gas, P reference, V reference. Then we bring this system over and bring it in contact with our system whose temperature we want to measure. Again wait till this thermometric system, which contains an ideal gas, attains a state isothermal with the state of our system, and then we measure the P and V of this ideal gas system, and then finally we use the formula which is part of the definition, that T of our system is obtained by using this relation, and PV reference is nothing but the product of P reference, V reference. Notice that on the right hand side we measure this pressure, we measure this volume, we measure this pressure, we measure this volume, and on the left hand side this T of triple point is defined. So this is defined to be 273.16 K, and all 4 quantities here are measured, and the only unknown in this equation is temperature. This is the ideal gas Kelvin of our system. Thank you.